This screencast represents a sample design analysis homework problem for developing process flow diagrams for alternative processes. The problem gives two different reaction routes used to produce desired solvent S from feed material A. In the first reaction route, 2 moles of A are reacted to form 1 mole of S and 1 mole of R, both of which are marketable products. The second reaction route reacts 1 mole of A with hydrogen to make S and methane. For this problem, we do not need to worry about stoichiometry. Now we have to sketch process flow diagrams for both reactions. For route 1, we'll start by drawing a reactor so that the reaction has somewhere to take place. Now we have to feed starting material A into the reactor, and we can do this via a pump. Coming out of the reactor, we have products S and R, along with any unreacted A. Assuming the reaction occurs in the liquid phase, we would need another pump to transfer the reactor effluent to the next stage in our process. The problem states that S and R are separable by distillation, so we'll draw in a distillation column. We'll assume that R is more volatile than S and A, so it will come out of the top of the column to be collected as product. S and A will leave the bottom of the column, but we still need to isolate the S because it is our desired product. Therefore, we need to add another separation column and assume that S is more volatile than A. S will leave the top of the column to be collected, while A leaves in the bottom. We can recycle the remaining A back to the start of the process with another pump to make the process more cost-effective. A purge line must also be added to prevent possible buildup of impurities. For route 2, we'll start with a similar setup as route 1, except this time we have gaseous hydrogen that needs to be transported to the reactor. We can do this with a compressor. Coming out of the reactor, we have S, methane, unreacted A, and hydrogen. We'll assume that hydrogen and methane are dissolved in the effluent, so we can use a pump to transport the effluent. We now need to separate our components. The easiest process step is to separate the dissolved gases from the liquid phase, and we can do this with a flash drum. Gaseous hydrogen and methane leave the top of the drum, while liquid S and A leave out the bottom. We can recycle the unreacted hydrogen, along with some methane, back to the start of the process. However, we need to use a compressor instead of a pump, since we are working with gases. We then add a purge line like in route 1. We still need to separate S from A, and we can do this with a separation column, where S leaves the top of the column to be collected. A leaves in the bottom and can be pumped back to the reactor feed with a pump, making sure to add a purge line. We now need to determine which process is more profitable. Looking at our diagrams, it appears that route 1 makes more economic sense. Route 1 produces 2 marketable products, S and R, versus only one, S, for route 2. Even if methane could be sold at a price similar to R, the methane would have to be separated from hydrogen, adding equipment and operating costs. Route 2 also involves the use of compressors, which are much more costly to operate than pumps. Therefore, we say that route 1 is more profitable. For more sample design analysis homework problems, please visit the Lafayette CHBE YouTube channel.